Bismillahirrahmanirrahim. Assalamu Alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus, National Book Foundation, Physics SSC 2. Today we will discuss unit number 12, Geometrical Optics, and SLO base according to FBISC requirement numerical problem question number 1 to 4 in part 8. So first we will start question number 1. In question number 1, given numerical problems, one statement is a concave mirror has radius of curvature is 15 centimeter. A small boy of a height 90 centimeter is standing in front of 10 centimeter. Find the location of nature and magnification and also height of image. So first of all write the given data. Radius of curvature R is equal to 15 centimeter. According to definition, radius of curvature is denoted by r and it is half of the focal length. Now, height of object h naught is equal to 90 centimeter and distance of object d naught is equal to 10 centimeter. Now, first of all, we find the focal length. We have f is equal to 1 upon 2 multiplied by r. Putting the value of r, then focal length is equal to 1 upon 2 into 15 centimeter. 15 divided by 2, that is equal to 7.5 centimeter. Now we will have required data to show distance of image, that is di, and height of image hi. We can find that. Now first of all also find the magnification. So write the formula. When we use the formula 1 upon f is equal to 1 upon d naught plus 1 upon di. Putting the value of focal length and d naught, so find di. And also height of object, find the given formula hi our h naught is equal to di our d naught. This implies that hi is equal to di our d naught multiplied by h naught, and magnification m is equal to hi our h naught. So using these formulas and find the required data. So first of all in solution we can write that the focal length is equal to 1 upon f is equal to 1 upon d naught plus 1 upon di. So we will rearrange the data. 1 upon di is equal to 1 upon f minus 1 upon d naught. So 1 upon di is equal to 1 upon 7.5 minus 1 upon 10. So taking the LCM, and that is equal to 10 minus 7.5 divided by 75. This implies that 1 upon di is equal to 2.5 divided by 75. Taking reciprocal on both sides, this implies that di is equal to 75 divided by 2.5. So di is equal to 750 means 750 divided by 25. 750 divided by 25, that is equal to 30 centimeter. So di is equal to 30 centimeter. Now we will find the height of image. So as we know that hi over h naught is equal to di over d naught. This implies that hi is equal to di over d naught multiplied by h naught. This is equal to 30 divided by 10 multiplied by 90. So 9 multiplied by 30, this will be equal to hi is equal to 270 centimeter. Now we will find the magnification, as we know that m is equal to hi over h naught. Putting the values, then 30 divided by 3, then magnification is 3 times. So that will be 3 times. Now we will find the nature. So the nature of image is real and inverted image can be performed. Now we will move the question number 2. In question number 2, the given statement of the numerical problem is that a 5 centimeter tall light candle is placed at 12 centimeter from the convex mirror of the focal length 6 centimeter. Find the location, nature and magnification of image of height. So, according to the statement, write the given data. In given data, focal length f is equal to minus 6 centimeter, because here mirror is convex mirror, and we will use the height of object h naught is equal to 5 centimeter, and also distance of object d naught is equal to 12 centimeter. Now putting the values and to find that required data, distance of image hi and height of image hi. Now we will have also find the magnification m. So distance of image di and height of image hi. Also find the magnification and nature of image. So we will solve the question by using the formulas. 1 over f is equal to 1 over d naught plus 1 over di, and also use the formula hi over h naught is equal to di over d naught. This implies that hi is equal to di over d naught multiplied by h naught, and find the magnification by using the formula m is equal to hi over h naught. Now finding the solution of the first part di, so as we know that 1 over f is equal to 1 over d naught plus 1 over di. Rearrange the formula, then 1 over di is equal to 1 over f minus 1 over d naught. Putting the values, then 1 upon minus 6 minus 1 upon 12. Taking the LCM, LCM is 12, then minus 2 minus 1. So this implies that 1 over di is equal to minus 3 upon 12. Now taking the reciprocal, and we will find the di. This implies that minus 12 upon 3. 12 divided by 3, that is equal to 4. So di is equal to minus 4 centimeter. Now we will find the height of image, as we know that height of image is equal to di over d naught multiplied by h naught. Putting the values, then minus 4 upon minus 12 multiplied by 5. So answer is that minus 1.67, but height of image not in minus, so that is equal to 1.67 centimeter. Now we can also find the magnification, as we know that m is equal to hi over h naught is equal to 4 divided by 12. 4 divided by 12 is equal to 1 upon 3. That is equal to 0.333. So in question number 3, a girl is standing near a converging mirror of the focal length 15 centimeter. What should be she stand to get? Here we can find the two parts. In first part, real, inverted and 3 times in large image, and also virtual, erect and 2 times diminished image. Now, first of all, according to the statement, write the first part data. Focal length f is equal to 15 centimeter and magnification is 3 times enlarged, so m is equal to 3. Similarly, in B part, focal length is same 15 centimeter, but image is diminished at m is equal to minus 2. So, first of all, we find the data in A part, distance of image di and height of image hi, and using the formula 1 upon f is equal to 1 upon d naught plus 1 upon di. That is also magnification m is equal to hi our h naught is equal to di our d naught. Now, as we know that m is equal to hi our h naught is equal to di our d naught is equal to 3, then di is equal to 3d naught. So we will put the value di is 3d naught. As we know that 1 upon f is equal to 1 upon d naught plus 1 upon di. Putting the value of focal length is 15, so 1 upon 15 is equal to 1 upon d naught plus 1 upon 3 d naught. Here di is also equal to 3d naught. So taking the LCM 3d naught and 3 plus 1. This implies that 1 upon 15 is equal to 4 upon 3d naught. So we have 3d naught is equal to 4 multiplied by 5 by cross multiplication. Here cross multiplication 3d naught multiplied by 1 and 15 multiplied by 4. So 3d naught is equal to 4 multiplied by 15, that is equal to d naught 60 divided by 3. 60 divided by 3, that is equal to 20 centimeter. Now we will find in B part, and using the same formula, as we know that magnification is equal to height of image divided by height of object, that is equal to di over d naught is equal to minus 2. Here di is equal to minus 2d naught. So putting the value of di is minus 2d naught, as we know that 1 upon f is equal to 1 upon d naught plus 1 upon di. This implies that 1 upon 15 is equal to 1 upon d naught minus 1 upon 2d naught. Taking the LCM of both terms, that is equal to 2d naught, so that is equal to 2d naught 2 minus 1. So this implies that 1 upon 15 is equal to 1 upon 2d naught. Here, taking the cross multiplication, this implies that 2d naught is equal to 1 multiplied by 50. This implies that d naught is equal to 15 divided by 2. So 15 divided by 2, that is equal to 7.5 centimeter. Now we will move the question number 4. In question number 4, according to the statement, a light ray enters from the air to water. Then reflective index n is equal to 4 upon 3 at the angle of incident 30 degree. Find the angle of reflection. Here one part is complete. In other part, if the light travels from the water to air, then the angle of incident is 40 degree. Find the angle of reflection. So here we can find the two side of the angle of reflection. One is air to water, in other is water to air. Now we can write the given data according to the statement. A part, angle of incident I theta I is equal to 30 degree and reflective index of air is 1 and reflective index of water is equal to 1.33. In second part, angle of incident I is equal to 40 degree and angle of incident of air is 1 and reflective index of water is 1.33. Now we can find the angle of reflection from air to water, that is denoted by theta r, and also in B part angle of reflection from water to air theta r. Now we will using the Snell's law. From the Snell's law, n sin theta I is equal to nw sin theta r. Now in solution, first of all in A part, from Snell's law we have n air is equal to sin theta I is equal to w sin theta r. Now we have rearranged the formula. Theta r is equal to sin inverse n air multiplied by sin I divided by nw, that is equal to sin inverse 1 multiplied by sin 30 divided by 1.33. Now taking the value of sin 30 multiplied by 1 then divided by 1.33. So the angle of reflection theta r is equal to 22 degree. Now in B part we using the same formula by the Snell's law, then we will rearrange that theta r is equal to sin inverse nw sin I divided by nr. Now in this formula we can find that sin inverse 1.33 multiplied by sin 40 divided by 1. Here taking the value of sin 40 and multiply by 1.33. Then answer is given that, so taking the sin inverse, then angle of reflection theta r is equal to 58 degree. Now here four numerical are complete. Remaining numerical in remaining video. Best of luck for the new videos and other knowledge. Subscribe my channel. Best of luck.